This is section 1.3, part A. We're going to be reviewing a little bit about quadratic functions, and we'll also look at some graphs of quadratic functions. First of all, a quadratic function has an x squared in it, and its standard form looks like this: ax squared plus bx plus c. Again, the defining feature is that it does have a second power, or an x squared term. The graph of a quadratic function is a parabola, and although I'm sure you've seen them before, I wanted to start by just drawing a graph of a very basic parabola. F of x, or y, equals x squared. And we'll do that just by creating a table of values and plotting our points. So I'm going to choose values from -3 to +3 for my x's. Just the integers for now. And in each case, the y is the square of the x value. Of course, we know that when we square a negative number, we get a positive, so 9, 4, 1, 0, 1, 4, and 9 would be the squares of those x values. And I'll plot each of those points on my graph. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And we can see this kind of a steep U shape, which is our classic parabola shape. And it's going to keep on going up forever. All right, a few things to note about parabolas. First of all parabolas have a turning point, either a local minimum like the one that we just saw here, or perhaps a local maximum if they're upside down. That turning point is called the vertex of the parabola, and that's going to be an extremely important point, one that we're always going to want to be sure we have in the right spot when we graph a parabola. Parabolas also have symmetry. In this particular case, it's symmetric about the y-axis, or we could also say that the y-axis is the axis of symmetry. If you imagine a mirror placed right on the y-axis, the parabola would be a reflection of itself in that mirror. We'll always try to identify not only the vertex, but we'll often be asked to identify and write down the axis of symmetry for our parabolas. When you graph a parabola, in addition to getting the vertex in the right spot, I'll ask that you plot at least 2 additional points. And if there are any, we'll always try and plot the zeros as our 2 additional points. If it's convenient, we'll frequently plot the y-intercept as well. When we have a quadratic function in its standard form, again, ax squared plus bx plus c, we usually find the vertex using our vertex formula. The x value can be found by taking minus b over 2a, and the y value can be found just by substituting that x value back into the original function. So we might say y is f of minus b over 2a. But again, that's just taking the number and plugging it back into the original function. The axis of symmetry will always be a vertical line, and it goes through the vertex. Since we already know the x value of the vertex, the vertical line will have equation x equals minus b over 2a. Finally, we want to find the zeros, the x-intercepts, and there are 2 ways that we know that we might need to use to solve them. If our function factors, that's usually fastest, and so I normally try my factoring first. If it works, I can solve the equation f of x equals 0 pretty quickly. When factoring doesn't work, then I'm stuck using the quadratic formula. It's not difficult, it's just a little bit more time-consuming. Just a reminder, the quadratic formula looks like this. X is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we'll need to use both of those methods of finding the y, or the x-intercepts rather, in the examples as we do them. So in our first example, we've got the function f of x equals x squared plus 6x minus 7. We know it's going to be a parabola, since it does have an x squared in it. And we're going to locate vertex, zeros, and the y-intercept, and then draw the graph. First of all, the vertex. We have our vertex formula, x equals minus b over 2a. In this case, that would be negative 6 over 2 times 1. That's really a 1x squared there. So the x value of the vertex is negative 3. To get y, I'm just going to plug that negative 3 back into the function. Negative 3 squared plus 6 times negative 3 minus 7. And let's see, doing the arithmetic on that, I'm going to get, let's see, 9 minus 18 is negative 9, minus 7 would be negative 16. All right, so we're going to go ahead and also find the zeros of this function. So let's just write this down. Vertex is at negative 3, negative 16. And the next thing we want are the zeros, the x-intercepts. The x-intercepts we can always find by setting y equal to 0. So I'd have 0 equals x squared plus 6x minus 7. And this one does factor. X squared is x times x. And thinking of two numbers that add up to 6 but multiply to negative 7, I'd have 7 and 1 plus on the 7 minus on the 1 will now add up to positive 6. So either x plus 7 equals 0 or x minus 1 equals 0, meaning x is either negative 7 or 1. Finally, I want my y-intercept, and I can get that by setting x equal to 0. So I just have 0 squared plus 6 times 0 minus 7, or y equal to negative 7. Let's put all that information on the graph. Oh, and it looks like I didn't do a great job here. I should have made my graph a little bit bigger. My vertex is down at negative 3, negative 16, but we'll just kind of guess here. Let's see, 12, 14, negative 16 would be about there. So there's negative 3, negative 16. Draw that again. Negative 3, negative 16 right there. Okay. Goodness, I'm having trouble with the computer here. Try that one more time. All right. Next, the zeros. Negative 7 is a 0, and positive 1 is a 0. And then finally, the y-intercept is negative 7, so I can plot that as well. And although it's not all of the points that I would perhaps have last time, I do have enough that I should be able to graph this parabola. Sorry, it's a little hard drawing a computer screen. That's not a beautiful one. I can maybe do just a little bit better over here. There, that looks a little bit more U-shaped anyway. You get the idea. All right, let's talk about the features of this graph. The axis of symmetry is always right through the vertex. So in this case, my axis of symmetry would be at x equals negative 3. The domain, when you're graphing quadratic functions, your domain is really always going to be all real numbers. X can be anything. We could plug any number into this function and get a y. Additionally, the x values on the graph, it keeps on going out to each side forever. So I'm going to say all real numbers are minus infinity to infinity. The range, however, is limited. Notice that the smallest y value on the graph is down at the negative 16. And so I would have to say my range goes from negative 16, the smallest y value, up to infinity. Y's can get larger forever. All right, in our next example, we've got the function f of x equals 6x minus 2x squared, a lot of people prefer to rewrite that with the quadratic or the x squared term first. So I might write that as negative 2x squared plus 6x. And I'll start by finding the vertex. Again, x is minus b over 2a. So that would be negative 6 over 2 times negative 2. Negative 6 divided by negative 4 is 1.5. To get y, I plug that 1.5 back into the original function. So negative 2 times 1.5 squared plus 6 times 1.5. And let's see, I think I did that one already. That one happens to come out to 4.5. So my vertex is 1.5, 4.5. All right, let's look at the zeros, or the x-intercepts is another way of saying that. I put 0 for the y value to find those. And I can factor a 2x out of that equation, which leaves 3 minus x in the parentheses. So either 2x equals 0 or 3 minus x equals 0, giving me x equals 0 and x equals 3. Finally, the y-intercept. This is where I put x equal to 0. So y would be 6 times 0 minus 2 times 0 squared, or just y equals 0. All right, let's draw it. The vertex is at 1.5, 4.5. Would be right about there. And a half, 4.5. I'm going to draw that again. The zeros are at 0 and 3. About there and about there. And the y-intercept is also at 0. So again, at the origin. Hardest time not resting my hand on the screen when I graph. That's what's happening here. It keeps on popping that up. I'm sorry about that. And if we go ahead now and just draw, this parabola is going to come out upside down. Okay, so there's our graph. Once again, I can identify a few features of it. The axis of symmetry, if I draw a vertical line through the vertex, is just going to be at x equals 1.5. The domain, once again, is always going to be all real numbers for these parabolas. And the range, in this case, I have a largest y value. There are no y values bigger than 4.5. So my y's go from negative infinity to a maximum value of 4.5. All right, here's our next example. F of x is 2x squared plus 2x minus 5. And if I start by looking for my vertex, x is minus b would be negative 2, over 2a would be 2 times 2. Negative 2/4 or negative 1/2, I could write it as negative 0.5. To get the y, we'll plug negative 0.5 back into the original function. And once again, I think I had that one worked out. If I find my notes here, came out to negative 6.5. So my vertex is negative 0.5, negative 6.5. The zeros. Zeros are the x-intercepts, and so I'm going to set the y value equal to 0. In this one, I don't believe this one factors. Remember to check it. You can think that you would need to find two numbers that add up to 2, but have a product of 2 times negative 5 or negative 10. Product of negative 10 and a sum of 2 is not going to work. So this is not factorable. We're going to have to use a quadratic formula this time. So x is equal to minus b, be negative 2, plus or minus the square root of b squared, it's 2 squared, minus 4, a is 2, c is negative 5, divided by 2a, which is 2. And just a matter of plugging that into your calculator, I got approximately negative 2.16 and also about 1.16. It wouldn't be a bad idea if you haven't done quadratic formula for a little while to pause the video and just plug those numbers into the calculator and make sure you come out with those answers, especially if putting big expressions in the calculator is something that you have had trouble with in the past. You want to make sure, for example, that when you plug it into the calculator, you use parentheses around the whole numerator. You'll have to do it twice, once for the plus before the radical and once with the minus before the radical. Okay, the y-intercept is where we set x equal to 0. So y would be 2 times 0 squared plus 2 times 0 minus 5, or just negative 5. All right, let's see what we can graph. First of all, the vertex is at negative 0.5, negative 6.5. Would be about there. The zeros we'll have to do the zeros kind of as an estimate. Negative 2.16, just a little past negative 2, about there, and 1.16, a little past 1, maybe about there. And then the y-intercept. So that y-intercept there at negative 5. And then we're just once again going to try and sketch in a parabola shape that goes through in all of those points that we just drew. I missed that one by a little bit. And there's the idea. Again, you have a lot more control with a pencil on a piece of paper, but you can get the basic feel for what it looks like even on my computer screen here. All right, our axis of symmetry goes through the vertex, vertical line, at x equals negative 0.5. The domain is all real numbers. And this particular one on the range has a smallest y value at negative 6.5, and then the y's go up to positive infinity from there. All right, we have one last example here. And looking at this, there's one kind of different thing that's going to happen here. So let's first of all start by doing the same thing. We want to find the vertex. X is minus b, negative 4, over 2 times a, which is 1, giving me an x value of negative 2. Plugging that in, our y will be negative 2 squared, plus 4 times negative 2, plus 6, which just came out to positive 2. So our vertex is negative 2, 2. The zeros. or x-intercepts. Putting 0 in for y and trying to solve that equation, once again, if you start thinking about a sum of 4 and a product of 6, there's no way to do that. So we're going to have to fall back on our quadratic formula again. X will be minus b, negative 4, plus or minus the square root of b squared, 4 squared, minus 4 times a, which is 1, times c, which is 6, divided by 2a. Now look at what happens underneath the radical this time. I have 16 minus 24. Well, that's going to give me a negative 8 under my radical. And we'll talk more about this next time, but anytime you try to take the square root of a negative number, we get an imaginary answer. So imaginary numbers don't appear on our graph anywhere. And for that reason, we're going to have to conclude that there are no zeros that show up in this graph. No zeros that are real numbers. All right, one more thing. Let's find the y-intercept. If I plug 0 in for x, I do get y equals 6 for my y-intercept. All right, I need to plot. So my vertex is at negative 2, 2, about there. The zeros, well, there aren't any, at least none that I can see on a graph because they're imaginary numbers. And the y-intercept is 6, about here. Now, using that information, I can kind of visualize what's going on. The vertex is the most important point, but really I'd like at least a little bit more information before I try to actually graph this. I'd like to have at least 2 points on one on each side of the vertex. So in this particular case, I'm going to make a little table of values, and I'm going to add a little bit more information to what I already know. When I make my table of values, I like to put the vertex in the middle. Negative 2, 2. That's the vertex. The other point that we already knew was 0, 6. And I like to take advantage of the symmetry of the parabola and say, well, from x equals negative 2, I went up plus 2 in my x and got a y value of 6. So if I go down 2 to negative 4 in the other direction, symmetry tells me I should have the same y value, 6 again. You could plug that negative 4 into the original function to check, but I'm going to tell you that it does work out. So let's plot those that one new point, negative 4, 6, about there. And that now at least gives me enough information I can start seeing that U shape, and I can draw my parabola a little bit better. All right, information about this parabola. Our axis of symmetry through the vertex is going to be at x equals negative 2. The domain, once again, all real numbers. And the range, I do have a smallest y value, y equals 2. And then the y's continue on up to positive infinity. Graphing parabolas in standard form, then, mainly relies on using the vertex formula to get the vertex itself, finding the zeros by either factoring or the quadratic formula, and then getting a y-intercept by just plugging in x equals 0. That usually gives you enough information to plot your parabola. If you'd like to practice this skill a little bit, there's a few practice problems in your notes next. You can pause the video and work those. Check your answers that are posted in my math lab.